Quiz 4 for Unit 2. Give the type of reaction, mechanism with curved arrows, and products for the reaction below. So first, you want to look at the type of alkyl halide. So what type of alkyl halide do we have here? We have a tertiary alkyl halide. So that means it's going to have to be SN1. We hadn't learned E1 at this point. So then we need to do an SN1 mechanism. So you got 1 point for the SN1 mechanism. So it's tertiary, so it can't be SN2, right? So again, SN1. First step in the SN1 reaction normally is the leaving group leaves. The leaving group leaves. The solvent reacts as the nucleophile. That's why it's on the bottom part of the arrow. So the lone pair on the nitrogen reacts there. The carbon is still there, and so are the two H's. Nothing changes there. So they're still there. So nucleophile reacts. The bromine that also left can act as a base, take the hydrogen. Those two electrons go to the nitrogen, so it's a deprotonation step. And we finally get our substitution product from an SN1 reaction. Couple things. People drew this as SN2 for some reason. Cannot do SN2 on a tertiary. They called it SN1, but they did an SN2 mechanism. Lots of people also, when they do this nucleophile reacts, these carbons get lost, these hydrogens fall off for some reason. Only do one thing at a time. Make sure you slow it down. We did relatively well on this. Comparing and contrasting this. So people that recognize it was an SN1 realize that a secondary alkyl halide makes a less stable carbocation, right? Not stable by hyperconjugation. People recognize that an oxygen versus nitrogen, oxygen is less reactive because oxygen is more electronegative. It holds its lone pairs tighter. Another final thing you only need to do too, lower temp needs energy for it to form a carbocation. That a carbocation takes a lot of energy, so a lower temp would make this reaction probably react slower as well. All right, so for this one, explain what the evidence tells you about the type of mechanism, either SN1 or SN2. The rate doubles the nucleophile. That tells you SN2 because the rate for an SN2 reaction is rate equals K times concentration of electrophile times concentration of nucleophile. And in SN1, the rate is not dependent on the nucleophile at all. And in SN1, the rate is not dependent on the nucleophile. B, a tertiary alkyl halide reacts faster than a secondary. That would have to be an SN1 because only SN1 can have a reaction with a tertiary alkyl halide. Also, a tertiary alkyl halide will form a more stable carbocation. C, the rate increases with an increase in the concentration of electrophile. This is actually both. Both the electrophile is included for both rate laws for both an SN1 and an SN2. So that one could be the concentration increasing there would be a rate increase for both. Number 4. For the SN2 reaction below, give the mechanism with curved arrows and the products for the reaction. So you had to recognize this as an SN2 reaction, which means it's going to be one step, right? 2 arrows in this case, and you're going to have inversion. So a couple things folks kind of got goofed up on. They didn't do the right mechanism. So recognize this as a leaving group. We saw this in a workshop. Nucleophile, carbon attached to this oxygen is the electrophile. React from the back side. As this oxygen forms a new carbon bond, this carbon-oxygen bond breaks. So 2 points for each arrow. Folks got the product, but they did not show the inversion. They needed to show that stereochemistry part of an SN2 reaction, that this went from wedge, and the thing that reacted had to come from the opposite side, so it would now be hatched. And then, of course, there's the leaving group. All right, bonus question. What anion is a more reactive nucleophile? Why? Must draw a picture. So this one is the more reactive because this lone pair is in an sp3 hybrid orbital, which is farther from the positively charged nucleus. This nitrogen is sp hybridized because it's a pi bond, so the lone pair is an sp2 hybrid orbital. Either way, that's farther from the this sp3 is farther from the nucleus. That's going to make this more stable. More reactive. This would be much more reactive. Wanted to see that picture, so you should draw me those hybrid orbitals. So sp3 versus sp2 hybrid orbitals.